Hello, guys. Let's talk about chemical equilibrium. To be in equilibrium simply means to be in a state of balance. In chemistry, we are going to have so-called dynamic equilibria. This means that the forward process and the revert process take place at the same rate so that there is no net change occurs. And we are going to use double arrows to show that we have an equilibrium reaction. So my favorite example for this is imagine that there is an island connected via a bridge to the mainland, and there are cars driving towards the island and from the island back to the mainland at all time. But the number of cars on the island is always the same, and the number of cars on the mainland is always the same. So there is an exchange between the cars. Some cars are sometimes on the mainland, some cars are sometimes on the island, but the total number of cars on the island and on the mainland is always the same. I hope this makes sense. So in chemistry, this basically means that in equilibrium, the products are being made at the same rate as the reactants, so the total amount of products and reactants doesn't change if neither the reactant or the product escapes the system. So let's take a look at this general reaction right here, and let's write out the forward reaction. So our reactant in the forward reaction is A2, and this is going to produce 2A. The rate for this reaction, let's call it rate sub F, equals to K sub F, which is the rate constant, multiplied by the concentration of my reactant A2. What about the reverse reaction? So the reverse reaction is exactly the same, just to the other direction. So my reactant here is 2A producing A2. What is the rate for this reaction? Well, let's call it rate sub R. It's going to equal to K sub R multiplied by the concentration of my reactant on the second order. So in equilibrium, the rates are the same for both reactions. So I can write out that K sub F, right, this part right here, multiplied by the concentration of A2 equals to K sub R multiplied by the concentration of A squared. I can rearrange this and get the following. A concentration squared divided by the concentration of A2 equals to K sub F divided by K sub R. And the quotient of the two rate constants is going to give us another constant. And this constant is simply called the equilibrium constant, K. So notice that here we are going to have the product in our original reaction on top and the reactant on the bottom. So we are going to use this to write out the equilibrium constant expression to other reactions. Now, what's cool about this is that the equilibrium constant expression depends only on the stoichiometry of the reaction, not on its mechanism. So the equilibrium constant expressions are different from the rate laws. Remember this very well. Let's take a look at this general reaction here where A and B are my reactants, D and E are my products, and I'm going to have these coefficients in the balanced chemical equation. The equilibrium expression is going to be the following. So K, the rate constant, sub C, and then the C just simply means concentrations, equals, in the numerator, we are going to have our product, so the concentration of D multiplied by the concentration of E, and I'm going to use the coefficients from the balanced equation as the exponents. So I'm going to have the exponent of D and the exponent of E there. All right, this will be divided by the same expression for the reactants. So the concentration of A on the exponent of A multiplied by the concentration of B on the exponent of B. All right, I hope this makes sense. Let's take a look at some sample questions. So let's write the equilibrium expression for Kc for the following homogeneous reactions. It's really important that the reactions are homogeneous. because we are going to have slightly different rules for heterogeneous reactions. But now all the reactants and the products in each reaction are in the same phase. So let's take a look at the first one. K sub C equals to product first, so NO2 on the exponent of 2, this is the coefficient from the equation, divided by the concentration of N2O4. All right, stop here the video and try to write out the equilibrium expressions alone and then come back and double check your work. Okay, let's do B. So K sub C equals, again, I'm going to work with NH3, which is my product, on the exponent of 2 from the reaction, divided by the concentration of N2 multiplied by the concentration of H2 on the exponent of 3. Let's take a look at the next example. So K sub C equals to the concentration of CO2 on the exponent of 3 multiplied by the concentration of H2O on the exponent of 4, and that is divided by the concentration of C3H8 on the exponent of 1 multiplied by the concentration of O2 on the exponent of 5. And in the last example, K sub C equals to the product cation right here. So concentration of Zn and H3 2 times 2 plus divided by the concentration of zinc 2 plus multiplied by the concentration of NH3 on the exponent of 2 from the balanced equation. All right, I hope this makes sense. See you in the next video.